Okay, so the only thing we've got on the agenda for today is to wrap up 2.15. That is not going to take us long. Don't forget, after our long weekend, when we come back on Tuesday, we have our first exam of the 9 weeks. It's only going to cover 2.13. Did everybody grab themselves a 3x5 note card? Okay, if you need one, just let me know, but you can still use one on Tuesday. Starting Wednesday of next week, we're on review, heading into Tuesday, May 13th. So it is not far off that we're going to have our exam. Thank you, Quinn. Now, as far as today goes, before we get started, I did go ahead and provide you some more resources. Thank you. Can it go after the lesson so y'all don't miss the notes? Yeah, it's only going to be real short. It's cool. It's cool. Okay. All right. Okay, so let's see, where was I? Okay, so starting next week, we're gonna have more resources than we're gonna have time to talk about. So I would encourage you, if you have a little bit of time, if maybe this is an area you're wanting to look into, I would encourage you to do so. Come on in for tutorials. But one thing I've already done, if you take a look at a new posting on our website, I did post a key with questions for 2.14 because we haven't had time to have a quiz over that. So I wanted to give you some sample questions covering that material. Now, I don't have a quiz over 2.15, but the next time you log into College Board, you'll notice that I did go ahead and assign you problems from 2.15. They're not mandatory. Again, if you want to work some College Board problems over semi-log plots, you've got some given to you. Okay, so you'll have access to all these resources as we go along. So are there any questions about that? Okay, well, what do you say we go ahead and wrap this up? Did anybody need a copy of 2.15? Okay, let me go ahead and get those real quick. Okay, okay, there we go. Okay, anybody else? Oh, you already have that one? Okay, okay, anybody else? Okay, so we're talking about semi-log plots, but one of our big ideas in this particular lesson was that if you take exponential data or an exponential function and you go ahead and put it in a semi-log plot. So we're talking about a plot where the vertical axis, the values change proportionally. Okay, what's going to happen is if those dots, the scatter plot's going to appear linear, even though we know we're still dealing with exponential data. Now, because it's been several days since we talked about this, this is actually going to be a very useful idea going into one of our problems in just a moment. When we're looking at a semi-log plot, we see the actual data. Like I see the point 1, 4. We know what the x value is. We know what the y value is. However, if I'm going to perform computations using these values for the y values, I have to do what? I can't just use, say, for example, 4. What do I have to do to it? Anybody have an idea? Starts with the L. We got to take the log of that value. You'll notice if we're going to do anything with the x's, it's just the x value itself because the horizontal axis, it's a normal axis. The values are evenly spaced. But we have to change the y values because the vertical y-axis, it's logarithmically scaled. Okay, the values are proportional, so we can't use the y value directly. So we'll remember that going into a problem in just a moment. Okay, well, let's take a look at number 4. This is a throwback to lesson 2.9, where we just want to plot some points on a semi-log grid. So remember, the very base of this grid that starts at 1, it doesn't start at 0. How do we number in the bottom region? We count by what? We count by ones. What about the middle region? We count by tens, and then up above we count by hundreds. So for example, if this is 1 here, then that's 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 20, 30, 40, and it just keeps going like that. Okay, well, all we want to do is plot some points. So A, which is 0, 200. So the x value is 0. I'm going to jump up to 100. So the very next horizontal line, that's got to be 200. So there's point A. Okay. Well, let's try B, 125. Okay, so I'm going to go out to 1. All right, I'm going to go up to 10, 20. So 25 is going to be halfway between 20 and 30. So that would be point B right there. Okay, so this is something we've done before. Any questions on this? Okay, so take a few seconds. Plot C for me, 2 comma 7. Okay, so where do we 2 comma 7? Okay, so hopefully you made your choice. So I'm going to go out to 2. And remember, this right here at the bottom is 1. 2, 3, 4, 5, 6, 7 should be right here. Okay, so there's C. Okay, easy, easy, easy. Okay, so who wants to show me point D? And don't worry about the fact that the X's are decimals. Every tick mark horizontally, that's 0.2. Okay, Naya, want to show me? So show me 3.2800. Okay, so we're a little off. So it looks like you went up to about 80.
Oh my god.
Okay. There we go. All right. Fantastic. Thank you. All right. Any questions? Okay. All right, so let's do this. Naya, who would you like to see plot point E? Matthew. Wow, you even got a high five going on. That's cool. Okay. So I need 4.6 and 1.5. Okay. There you go. Because remember, the very base is 1. So that would be 1.5. Fantastic. Okay, any questions? Easy, right? Okay. Well, let's see what this box has to say. Linear models for a semi-log plot. So given the exponential model, y equals a times b to the x, the corresponding linear model for the semi-log plot is given by, so we have y equals log base n of b, x, plus log base n of a. Now, I know that looks strange, but this is just the logarithms version of slope-intercept form. Okay, you're going to see down here at the bottom that log base n of b, that represents our slope. Log base n of a, that represents our y-intercept. Now, n is always going to be the base that you're using in a particular grid. So if you take a look at the problem we're about to do, you'll notice it's base 10, so that's why I have n equals 10 here. We're going to be using the common log for this one. Okay. So even though I know that in a semi-log plot, we're dealing with exponential data, okay, the scatter plot that's formed is linear, we can actually write a linear function to represent the graph. Okay, and that's what we're doing in example 5. Okay, write an equation for the linear model in this form. Well, what's the most important thing to a straight line? They all have what? Slope. You got to find the slope first. So we refer to that as average rate of change. So AROC. Okay, so this is simply the difference of the y's divided by the difference of the x's. Now, we're using the data from example 3. Okay, now if you flip back, you'll notice that that's the same table. I just went ahead and copied that here so I don't have to go back and forth. And you could use any 2 points you want. Okay, let's go ahead and say that we're going to use 140 and 260. So the difference of the x's, I'm going to say the denominator is 2 minus 1. But up top, I cannot just put 60 minus 40. You remember what we talked about in example 2 a moment ago? Okay, because the y values, the vertical axis, those values are proportional. What do I have to do to those numbers? Remember, it's not 60 and 40. I've got to take the log of those. So I've got to take the log of 60 minus the log of 40. Okay, now this is divided by 1, so we don't have to worry about that, but let's go ahead and see what we're going to get. So I'm going to go ahead and say log of 60. And remember, you can put in 10 if you'd like. If you don't, it'll still recognize it as the common log. So control log, I want 40. So the log of 60 minus the log of 40. So I'm getting my average rate of change, let's say 0.1761. Okay. So I'm going to come on back over here. So 0.1761. Yeah. Sure. Okay. All right. So for our equation here that we're trying to write, I've already got half of it right there. If this would let me draw a check mark, that would be super cool. Let's try that again. There we go. So I've already got my slope. Now I have to use that slope to help me find the y-intercept, which is being represented by log of a. So from here on, we already know n is 10. So I'll just go ahead and say like log of a, a common log. Okay. So let me get a place where I can find some room here. This is what we want. We want log y equals log, okay, of b times x plus log of a. So I'm using n equals 10 here. Now we just found that our slope is a 0.1761. So 0.1761. Now what we have to do in order to find the log of a, we've got to use another point from the table. And again, because it's a linear function, it makes no difference which one we choose. Okay, let's just go ahead and use 260. So in x, I'm going to go ahead and substitute in 2. That's a 2 right there, plus the log of a. Okay. Now, what am I going to set this equal to? Oh, remember, it can't just be 60. It's got to be log of 60. There we go. Because this data is coming from a semi-log plot, the y values, we have to take the log of them. Okay, well, the first thing I'm going to do, let's take my slope and double it. Now, again, I went ahead and rounded so that we could have an answer on my paper, but I'm going to use the exact value in the calculator because I don't want to round in the process of solving for another value. So there's my slope. I'm just going to go ahead and double it. Here's what I get. So let's say 0.3522. Okay. So that would mean that log of 60 is now equal to 0.3522 plus the log of a. So what's the last thing I got to do in order to solve for log of a? What am I going to do with log of 60 and the 0.3522? We're going to subtract them. I would have to subtract that over. Okay. So let's see here. I'm going to take the log of 60. Okay, let's go ahead and subtract. And then I'm going to use my touchpad to go ahead and choose the value that I want to work with. Okay, so I wanted that product right there. All right, so here's my y-intercept. So let's say 1.4260. Okay. So log of a is about 1.4260. Okay. So if I go ahead and take the slope and the y-intercept, if I plug them into the equation, boop, there's my slope-intercept version. Okay, it should be 0.1761x plus 1.4260. Okay. I mean, it's exactly what you would have done back in algebra to go ahead and find the equation of a line. You just have to remember from a semi-log plot, you got to take the log of the output values, the log of the y's. Okay. All right, does anybody have any questions on that? Anybody confused? Okay. Well, we got one problem left, and that's it. So part B, it says using the linear model that we just found, write the equation of the exponential model, y equals a times b to the x for this data. Okay. Well, in the linear model, didn't we already have the variables a and b? In fact, remember your slope was log base n of b, right? Okay. Now, because we know we're working with base 10, I'm just going to go ahead and say log of b, and let's actually put the slope that we found. Remember, because this represented the slope, so I'm going to say 0.1761. And then the y-intercept was represented by log base n of a, excuse me. So I'm going to go ahead and say log of a, and let's plug in the y-intercept that we got. It was 1.4260. Well, does anybody see where I'm going with this? How am I going to solve these in order to find a and b so that I have my exponential? What did we do in 2.13 with the log equation? Let's make it exponential. So for this first one here, I'm going to take base 10, raise it to the power of 0.1761. That's going to give me my base B. Same thing over here, 10 to the 1.4260. That's going to give me my leading scale factor A. And now I'll just turn into the calculator again. Okay. So let's see here. So I'm going to go ahead and say 10 to the power of. So the first thing I want is the slope. So I'm going to go ahead and choose that value. Okay. So here's my base of 1.5. And then I'm going to go ahead. Let's do this one more time. But now I'm going to choose the y-intercept. Okay. So here we go. So 26.6 repeating. Okay. So, so B came out to be 1.5. A came out to 26.67. So if I go ahead and put these together in the model, that would be the exponential used to create the data in the first place. And now what's really cool about this, you can actually work backwards now. If you know the value of A and B in your exponential, if you go ahead and take the log of each of those, that's going to respectively give you the slope and the y-intercept, so you would also have the linear equation. See, they can work through each other. Okay. Any questions? Anybody having a hard time? Anybody lost? Okay. And guess what we just did? We just finished the entire curriculum for the school year. Okay. Now we're on review. Hey. Yes, give me 2 seconds. Okay. So are there any questions before we go ahead and wrap this up? Yes. So you two can take off now. Thank you for hanging.